Hello, everybody. I really appreciate that too much of you come here to the event to listen some great stuff I want to talk to you about. And I hope you enjoyed the presentation, and back there I hope you enjoy my voice, because I'm not sure if they can reach anything else. Okay, I think the most of you know already the Node.js, so I will try to make it briefly. Also, I would to tell you what you hear today. I was on a lot of conferences, meetups, and so on at Prague, but usually it was too general. I heard good stuff about deploying microservices, about cloud services, and things like that. But when we actually started to make first microservices, you start with a lesser one, then you continue and you grow. I really did not have any much support, even from Google, even from Meetups, and so on. So I will try to a little skip the things about the deployment and things so on. You can really read great articles. You can go to the Meetups about Docker, Kubernetes, cloud services, and so on. And I will try to tell you why the microservices are good. I will give you a few examples of our real usage, and that's it. So to just clarify what's the Node.js great about, I write it here. So it's one thread. The code you write has one thread. That means you have no deadlocks, you have no synchronizations, you have no thread creations. Of course, it has its drawbacks. If you run a CPU expensive algorithm, you can kill the whole task. You can you can kill the whole server if you just don't catch an error and it's propagated to the root. You can shut it down. This is not usual if you are coming from G2EE or something like that. If the thread fails, it just fails and everything is okay. But this is if you consider it from the beginning, you can really make great services. The next thing, at least I really enjoyed, is the npm install. I don't know if you made to make files in C++, if you made AND jobs and things like that. You really need to have deep knowledge about what we are doing to just compile your project. You want to do it. npm install. Who doesn't know Node? You just put the libraries or modules you want, the version, and everything works. I know there are some little issues, but I never hit them. JavaScript, the great tool, and yeah, it has two sides of coins. The first great thing is you can do almost anything. The bad thing, you can do almost anything. So if you are doing it good, it can be a great tool. Public modules, it's JavaScript. It means everything is open source. Of course, you can obfuscate it and do things that make it not easy to copy your code, but as far as I know, every module I opened to look inside what's happening, it was open source. And of course, it's asynchronous. It means into G2EE or some typical programming languages, if you need to load from Elastic, from database, from Firebase database, and so on, it's usually synchronous. So you'll go one, two, third, next things. It's really bad if you need fast request and you just want to work it together. Of course, you can do it, but you have to spawn workers, new threads. It's really difficult. In Node.js, you basically can't do it different way than asynchronously. This is the really nice page. It's modulecount.com, and you can select different packages you are interested to compare. This is from the almost beginning of programming age of new era. This is us. And I think the hype is really real. I know the module counts is just one metric. That it also means there is a lot of garbage of modules that have only tens or hundreds of downloads. But this shows something. This shows that the community is huge and it wants to develop new things. Don't take it too harshly. I love Stack Overflow. I have several thousand points myself. But I found the best argument for Node.js. I thought, why is Node.js so good? Why, for me, why I am so happy when I'm implementing with it? And I found out I'm not going to Stack Overflow anymore. I just write things. And it works only if I'm using a new module or something and the description is not good enough. I found a good solution there, but I am not spending an hours to try to configure everything perfectly because it just works. Usually it works if you know at least a little what you are doing, of course. Yes, and there are the microservices in 2017. Well, this is interesting thing to think about, that the microservices are not a new concept. You can do microservices 30 years ago, just wrote some C++ code, compile it, then run another, it can communicate in some way. So this is not a new thing, but in the last few years, it just became a huge thing. And it's the several factors that that is important for it. There is not everything I can put it there, but just main thing that comes up to my head. So prices for services, they are really cheap. No matter if you are using cloud or anything else, it's become cheaper and cheaper, and it's better for you to use services than implementing and handle it by yourself. There's Docker. I just want to know how much of you know Docker, for instance. Oh, that's really nice. How much of you really use it in your projects in production environment? Okay, that's still really good. I didn't expect that much. Yeah, for those who doesn't know, the Docker is an amazing tool. You just, at least a few years ago, you really need the admins that configure stuff and do everything you need. But now you have just the DevOps, and they put everything into Docker, run it, and it does not depend if you run it on Google Cloud, if you run it on Amazon, it just works. The cloud, it works well with the Docker. It's easy to scale, easy to maintain, and things like that. And Node.js, good thing also is that it starts in a few seconds. You just don't have to wait a minute after it starts. So if you need auto scaling and stuff like that, it's just killed and restart really, really fast. Well, I think that the concept that is really interesting, and this is good to say, is a loose coupling and high cohesion. These are two principles, each of them saying something little different, but at the end they are important to keep them together. And this is not the official definition, but it is easy as it sounds. Loose coupling means keep your modules, microservices, and everything separated, communicate through the REST API or something. High cohesion means if these things belongs together, keep that things together. This is why they are here. And in a history, it does not mean that this is history, this is obsolete. You will still use classes, you will still use design patterns. And you know, the huge corporations usually use something like enterprise service bus and things like that. But at this time, the microservices really hit the ground and are really great to use. And this is the common data transfer I usually see today. Well, some older applications use VCL, and so I don't like it too much. You really have some libraries for it, some dependencies. You don't have to read it just as it comes. REST API. I think the REST API is really great, and sometimes you find out that if it is as simple as it can be the best way. Because if for example we are using usually JSON, if you give someone a REST API JSON response, even if it is not a programmer, he is usually able to say you, hey, there is a person, he has a cat, and the cat is 12 years old. That means that this is as easy to understand that even if you as a programmer can easily read it. And one which is also very common today are some queues. We are usually using Cloud PubSub, there are Rabbit and things like that. And they have one big disadvantage, is library services dependent, but for some use cases, they are much better than REST API, and one of my examples is also dependent on it, and I will show you why. Okay, so let's start with our first example of successful microservice that we developed. So how much of you know the parse and use it? It was Okay, so it's not that much people. The parse was a great service from Facebook, and it was used for sending push notifications. It was really simple, great to use. It has SDKs for all platforms, and we would never switch from it to anything else. But at 2016, the Facebook said, "We are sorry, we are putting it down." So after you have the year to switch to something else, and everyone must switch to something else. The good thing was they made it public, so you could download the source code, you can run it. It was written in Node.js and MongoDB, so it was really able to set up. But still, we were not sure. Would be community big enough to handle the new parse? Would it be still bug-free and everything? And also, this got to up our minds. If Facebook is not able already developed applications for push notification, which I think was the best on market, doesn't want to handle it. Some startup would do it. So after the year, we just have to switch all our apps. There's also one thing that I'm from a company that we have like 15 applications active now, and we are developing more. And if you have to switch something, 15 applications, it's really painful. You really don't want to do it. So next thing was, okay, by that time we were talking about it, the Firebase cloud messaging in the ground. You say, okay, it looks modern, it looks great. So it's not that difficult. You just have a few fields, you select a few devices, you put it there, and so on. And actually, it was not difficult. We actually put our requirements, which is important for us. So must always deliver a push. We have some applications where it is really important to push be delivered. For example, I think I can say it, there's a babysitting. I'm not sure if it's running in Germany right now, maybe only in Czech Republic. But it's simple. You have a child you want to care about. You want to go to the theater. And you really want to push notifications to hit your pocket and say it's okay, in 1 hour there's a babysitter, you can go to the theater. So in some applications it's really important. Also, downtime is not acceptable. If you have real downtime, it can be not delivered at all because the servers doesn't know what to do if the call fails. Also, developers should get info about progress. So when we are developing, we just want one entry when developers says, okay, we send this message, what's happening with it? And also, server must be able to touch devices by custom variables. It's simple as that you put, for example, user ID, you put language, you put Android, iOS, and you want to select by these parameters the devices you want to send it in. And this was our solution, and it's up and running, and it has about 100 million requests per month, which sounds really great, but if you divide it, it's not that much, but I will not say how much is per second. Okay, so this happy smile over there, that's you sending an update of your device to our push server, or it's a server that is trying to send you push notifications. Well, the first thing is, it's come to the API. It's the simple API with the REST API, that's why we call it API. And as simple as that, it just only gets the request and it puts it in the queue, nothing more, nothing less. The reason for doing this is that it's almost bug-free. It has no downtime, and it can do really so much requests, and it's not dependent on the database or anything else. The great things about queues, we use the PubSub queues because we are running our servers on Google PubSub, on Google, and there is a Google PubSub. The good thing is that if you take message, if you put message into queue, it stays there forever unless you take it. If you take it, you have some time to acknowledge it. So I take it, I do something with it, like sending it, and then I have to acknowledge it back. So I say everything was fine. If my server fails, then the message is still stored in the queue and will be delivered after a few minutes. So this is how we managed that push is always delivered. So this is the select. It's the most important part. You just communicate with MongoDB, and MongoDB is great for these custom variables. You can put anything you want, user ID, languages, and so on, and select by it. And the last one is the sender. And yeah, what it does, it sends. So it's communicate with the Firebase Cloud Messaging. So it's a simple architecture. It's nothing really huge, but it works really great. This is the important thing. How I said, we are not developing new things. You can do it before, but if you have a cloud, if you have auto-scaling and things like that, if there's a lot of requests, you just auto-scale your APIs, so you have like 10 of them, then it's stored in the queues. If this is not fast enough, it can auto-scale, and that's why it is shining. And the important thing is that everything of it using Winston Elastic is sending logs to the Elasticsearch, and these are specific logs for the developers. So when they put something to the REST API, they just got return, and they just got 202, which means that the request is processed, and they just got some ID. If they put ID in our system, we can say them, okay, it goes there, and sorry, you have a bad key or something. Or we send it, and these are the tokens we selected. This is basically what I said, but for someone, if it reads, it would have made more sense. Yeah, I think I said most of it. So the queues, these are for the safety. MongoDB, for the variations of variables you can select by microservices. Of course, the good thing is you have 3 microservices, each is doing something different, and you have low code base. If anyone comes to this project and he tries to develop in it, he just change only one project, and it's much easier than if you have coupled it all in one huge mono project. Yes, and with the cloud and load balancer, you have no downtime. It is even when you are updating your applications. If you are updating some application, you have several instances running, and some of them are just killed. They are updated. Meanwhile, these others that are running, they are handling the request. So you have basically no downtime. I think that good consideration to upgrade this schema. I will return it. I think this part can be very well replaced with some function as a service, where you just, this is as simple as it could be, so you can just write even Amazon or Google functions, which is still in alpha, but we are trying to get involved in it. You can just rewrite this service so you do not have to manage it, and the thing about be always up, never have downtime can be even more safe. Sorry. Okay, and this is the second question.
Sorry, there was Elasticsearch in the corner.
Pardon? Pardon?
Elasticsearch is there. Elasticsearch.
Elasticsearch.
Yeah.
Yeah, Elasticsearch, we are using it. We are using it especially for logging, and the good thing is that it logs the data structured, so you can very easily find by it. And I really recommend even the Winston Elastic, even the Elasticsearch. These are great services we are using. Oh, sorry. Because I don't think it really works. So you had a little spoilers. Okay, so we are there. Okay, user service. This is a second example. We already had the Node template. As I said, we are making a lot of applications. It's usually mobile apps, but we are making everything, so servers and things like that. And we developed just a Node.js template for the use case we usually most use. In our case, that was a logging registration. You want to change your emails. We are able now to register by Facebook, Twitter, LinkedIn, Google, and you just have a 15 projects, and you want, if it is possible, you want to keep them as updated as possible. So this is how we started. So we have this Node.js template that was working fine. We used the similar code in multiple projects, basically project stars with taking the Node.js template and writing into it, because it has usually the basic start, you want to do something. But the problem is when you are updating it, when you are spent hundreds of hours in this server, the code is too specific. You just can't update the Node template and just move it to the existing applications. It's not that easy. Also, this was a good question. Do we need authentication data after the validation? Basically not. If someone sends a token and we validate it, well, it's validated. You just want to know what is this user. You want to know authorization rights and things like that. And the last thing, if you have multiple microservices, it's a common problem that usually have one entry point, multiple microservices, but you usually want to authenticate it in one point. And this is what we did, and it actually worked well. Again, it's not difficult. We have just the gateway. This is for the consideration. You can use the cloud services for gateway. We wrote our own because we thought it's really easy. In fact, it was not that easy, but right now we have a functional gateway that really works. In code, I will show in a live demo this gateway there is shown there, and it is already updated on GitHub, so you can even use it if you want. Well, and the flow is really easy. You go to the gateway. If you have authorization token, it asks user service, who is this user, and it just validates it because it usually knows the email, ID, and the tokens like refresh token, access token, and things like that. So we are inspired by I don't know how to read it. OAuth too. Yeah, we are inspired by it, but we are not doing it exactly the same because in our case that was too complex. So it validates it, returns to the gateway. Gateway repacks it and sends to another microservice. Good thing is about that is using JVT tokens. So how much of you know JVT tokens? Oh, that's also good. The good thing about this is that we can send the basic user info in a header, and it's the standard way. It's not something we are implementing. So in gateway, there's only some basic info. In access token, it's validated. There's returned the whole object of user, which usually only have ID, email, and authorization rights, and then it sends here. When it gets here, it just takes it, it's unpack it, and you know that this user is validated. You don't have to care about validations anymore. So this is again, I think that I said everything. There's a gateway for authorization and a user service that handles it actually. Gateway that is using JVT tokens and any microservices there is more. You just unpack it and you are fine. The advantages. Well, as I said, if you have a lot of new projects, it's really great that we have just one template. We update, we add Facebook login, and we put old code here to the trash and we put there new, and it works because all the authentication is there. Also, the lower code base. Every project has separated the user servicing, so you have lower code base. It's easier to access. It's easier to not messing things up. And also, this is something to consider. We did not have really a problem with it, but it comes to my mind that if you are using bcrypt, it can be really CPU heavy, which is a good thing because it's not that easy with the hardware. You can't unlock it by the hard way that easily. Well, and one thing, and I want to tell you about the stateless. The important thing what to not do is you must be stateless. If you try to do transactions between microservices, you will burn in hell. And we have our own experiences with it. So remember, I think this is the most important thing to tell you today. If you will start, if you do not have experience to design microservices. If you have several microservices, each microservice should have its own database. It means that the thing that you have one big database, you put a transaction in it. If it fails, it's all rollback. It's not anymore, because if you have 5 microservices which is communicating in some way, if in the time it appears here, it can't be here. So it's really good to design from the beginning that if I can't have the data synchronized from the beginning, what if I think about, okay, so if there is not from the beginning, what if there would be after 10 minutes? It can't be that problem. And if you identify the problems you have and things like that, you can synchronize things. For example, by crons, or very good is using place alone. So you put user to your microservice when he comes in. So he is already registered in the user service, but in other microservices he's not existing. And you can lazy load him right there. You just check it. And yeah, this is it. Anything can fail in the middle, and it will. This is the most important part. So I think there is one nice fail we had. I'm really sorry. Forgot the spoilers. Okay, so this is our first microservice project that really fails bad. And what we thought, we said, okay, there's a gateway and there are users. We put it together and we are gatewaying something to the gateway itself because it has user handling, and there is some core which are doing business logic. Well, that should be okay, right? It is not, because the code grow massive with something like, it's not gateway even more ever. It's not like a simple gateway, because some things it just deliver to the core, but some things it has to call functions inside itself. And I wrote a few things. Sorry. Yeah, the worst thing was the user creation. When you were registering user, it comes to the gateway and user service at once. Then it goes to the business logic. Business logic said it has all required fields like telephone and so on. And if it has, it created it. Then it goes back. Then it was created in the gateway user service and returns back. And what happens when it is created in this business logic, but something fails in the way back? You know, you have inconsistency, and if you are not prepared for it, you can get to the situation that the user is not logged in or registered anymore in any time unless you manually fix it. Do you really want to do it? So these are those transactions. Those are things that you are not stateless. As I said, we had to implement a lot of code into the gateway user service, and it was really mess up. And also the solution became too specific that we cannot reuse it. It was bad. Well, this is almost end of my presentation. So one point is expect the unexpected. And this photo is from yesterday when I was driving to Berlin. And I think you can be happy that I did it yesterday to have enough time to prepare for this talk. So when I tried the second time today with the bus, it was much better. I'm here, right? Okay, you know, maybe you say to myself, oh my God, he put so much code here, it's not readable. You are right. And the point of this code is to not read line by line. I just say what is this. So even Node.js is a great thing. If you are using it bad, it will be bad. So this is code that we got one application, we did not develop, and this was the thing we found up there. And I will tell you what it is. It's the payment. If you are paying something, you need to generate we call it a variable symbol. You know, I don't know if it's international name. If you are having payment, you have just the symbol, or variable symbol. It's called. I don't know the unique symbol that you identify the payment.
Payment ID or something.
Oh, payment ID or something. So well, you generated one, and you have really good chance it's good. But what if it is not? generated second time. But what if it fails after the second time? So, and of course you have a nice sketching after each failure and things like that. So this make project really readable and nice. So even think about what you are doing, it's important. Well, and here is a live demo. It was really hard for this talk to think what to program because it was too complex or too simple for me. So I just pre-program it and I will just show you what it does. But it's not that difficult. I will return here. Sorry. If you remember that we have the gateway, the user service, and the other microservices.
The font size?
Pardon?
Can you increase the font size?
I'm not sure. Does anybody know?
Yeah, we can go to, it is very strong, right? Yeah, file, go to preference or settings like that in the first, I think in the file.
Settings?
Yeah, settings, right?
Okay.
Editor, right? Yeah, that is font, right?
But, oh.
You can increase the size to 70.
Okay. Did I click something better? Okay, that is something I should be prepared for.
Can you just do Control+?
Control+?
Yeah.
Control, command maybe?
Control and this plus.
Well,
You can just move and
now,
then after you just close this guy.
okay.
Now you just,
Okay. I have never tried to use the.
or maybe we can have, oh, come on. Okay. There's a presentation mode here and the presentation mode. There's a presentation mode.
Okay. I am not sure how to switch project right now, but we are. Okay, so and I really don't need that file right now. So anybody?
Double shift and then.
Oh, but I really want you to see it in structured way if it's possible. So do you have any ideas? I pressed F12 and I don't know why it works. So this is the very simple Node.js project, and the main part is here the gateway, which is, you remember, is just gateway things. The only thing which it has, which it can offer more than just simple gateway, there's some part that is a validating access token. And if there comes a request that is directed to another microservices and it has authorization header, it first validates access token to the user service, and then it returns and it repacks the user and send it to the microservice you want. Usually it is the one with the business logic or payment service or something like that. So this is it. It just uses JVT tokens. You have just basic config, and it does not do nothing more. And now I need to switch to another project. Okay.
You try view and presentation again?
Yeah. No. Okay, so this is the font. Okay. Okay, so this is a simple. This is a really simple Node.js service. It starts in server.js. It loads the express passport and it starts. The important thing is the roads. So it loads roads, and as you can see, it has some authorization. It has some truth. So it loads these modules. And if we look inside it, it's just controller. It's a controller that says at register, we have user register, and at user register, this is very simplified, but I just generate here access token, which is JVT token with some variables. We put it to the out, we put it next, and that's really everything we does. And the last service, I'm not really sure how I switch it to the last time. It just happens.
F12 maybe?
That I tried also. Oh, sorry. Yeah, I think I put it to sleep. So one moment.
Your line.
Well, I do not see the presentation again.
Presentation mode, I think it's already maybe in the okay.
Maybe F1.
Maybe if you decrease the font size to 12 again, you can read the menu.
Maybe. That would be a good point.
And then I add something that's a bug in the UI.
Go back to files.
Yeah.
Human.
Okay.
No.
Huh. Maybe it was the different project, but yeah, finally. Yeah, and this is some of your core functionality. It's the same from the server. You go to the roads. From roads you go to the route, and here you call some of your controller, and here you just put out some message where you use user who does not know there's a passport. It is very used module that just takes things like authorization tokens, but even any kind of authentication you can imagine. And it's the simple wrapper that you just write a simple function like this, and you see that it just unpack it, and if everything's okay, it just put to the rec user, it put the user you have in your token, which is very useful. And now I want to show you in the Postman. Sorry. Okay, so Postman is the really great tool. It can do a lot of things, and maybe one important thing I can show you right now. So we have these services up and running, and we really tried to size up the Postman some time ago, but we were not succeed. But maybe, yeah, I'm sorry. You have to imagine what there is. Well, there are just two endpoints where we have some register. There is a register, and if you click send, and you have some environment set up with the base URL, which if you hold it, you can see the what it is. It just communicate with the user service, and back it returns the access token where it's user packed. The good thing about the Postman, if you know how to use it, and I really recommend it, is that in these tests you can do real lot stuff. So now we got a responsive access token. In tests, you can check if everything is okay, which means if it's 200, and you can remember your access token in your environment, which is this one, which is very helpful because when I use it in another request, you can look to the headers. There's an authorization header, and it has access token, and I don't have to manually copy it to the clipboard and then paste it. It's already there, which is very helpful, and you can set up as many variables as you want. If we send it, we can see hi user Libor in Berlin. Here is the list, and then return something. If we look to the register, to the body, you can see that my name is Libor in Berlin. And sorry. And this is everything I have for you today. Sorry for the problems at the live demo. I will be prepared more.
The JWTs, are they signed, the secret or share secret?
Yeah, the question was if we have signed JWT tokens. Yes, we have signed all of them. And the interesting thing is that we have different secrets to the outside. So when you are on mobile app and you register, you receive some access token packed in some secret. But when you do some request, it goes to the gateway. It just resends it to the user service. User service returns to the user, and we repack it with another secret that we send to other microservices.
So then every request that is being made to gateways, so like as a microservice, will always trigger one request to user service, right?
Yes, but if you want, you can write a soft verification, which you used for some applications, where you can just unpack it, and if you believe in the token, you just send it next. But basically, it's something we want to do. We basically want to make every single request authenticated, and we want really to ask the user service for it. So that was the use case. So we have questions there.
I had like a similar question, but I think like from an architecture point of view, what we want to do is we want to share the secret between the microservices and be able to validate the token on the microservices themselves. Because the JWT verification is so simple that it doesn't need an extra service. Because now you have like a single point of failure in the application, and like all the services will not work anymore when the user service is not available. And that's not a good pattern, actually.
Yeah. The question was if our gateway is one point of failure.
The user services, because that's to validate the token.
Yeah, well, so the question was if the user service is one point failure of the whole microservices. The answer is yes, but as we thought about it, if we want authenticated user, we want to store them in some place, and this part just must work. So we take the risk for it, and yes, this of course you are right, but we did not find any good workaround about it.
Well, the workaround is you have a mechanism that like publicates the active private keys for the tokens to validate them in the microservices asynchronously. So the microservices like learn about the keys from the OWL service, but not directly talking with it, but with an asynchronous process. This way they can validate all tokens. The user information that you really need is usually just, for many services, often just an ID. So obviously you don't need always, all services don't need always the whole user information about the user. Just certain services, no, they can still talk to the user service with it. But the services that don't need all the user information, that can just rely on user information that's encrypted in the token, don't have this dependency anymore to your user service. Also, it gives you the ability to distribute your microservices like more globally and don't having like latency impacts with the validation with the user service. And this would be like the architecture where you make the most out of your JWT and you really reduce, like eliminate this like single point of failure.
I think this is a good point.
the user service is mostly to make maintenance of code that validates the user easier. Did you consider at some point to simply use an NPM package and distribute it with all your microservices, which will help to achieve what you just described?
I'm not sure.
So basically, your user service, you said, is doing all the verification of the token.
Yep.
And the main reason you wanted to do this is because if you change it once, you want all the applications to have the same logic.
Yes.
And so,
well, it's not that simple because we do not have one for all projects, but we have just one template. And yes, we have to copy the code actually in the existing project because you can't do it automatically because sometimes it can be really critical to change something like that.
In your architecture diagram, you had the API, and then with something in queue. How the client gets response? Do you keep the connection open, or
he receives the 202, which means his request is accepted, and he does not know the whole chain because it can take minutes.
Sure.
Yeah.
So the response is asynchronous. You get it per WebSockets.
Well, this is the reason we use the Elasticsearch. The user receives some kind of ID, and when he puts the ID in the system, it shows him all the related things that happened to the message in all the chain.
So it's polling.
Pardon?
So you would be polling for the progress.
Yeah. Well, the point is that you really don't want to keep a few minutes alive the connection and then tell the user, okay, we save it. So you just put it there. You know it is not already there because you got 202, and you hope it is as fast as possible there. And you can log your status by using the ID.
When you get mad, you get a lot of loads of your clients, a lot of clients, and therefore each time there is a request.
Well, usually they don't usually make requests to these IDs and things like that. They just put it there, and that's everything what they did.
I have one different kind of question. Like, as you're presenting microservices, so for microservices, the serverless architecture became very popular nowadays. Like AWS Lambda, and there is a framework called serverless. So, how do you compare with serverless framework with microservices, or how do you feel like as you are working for your company with microservices? So, how do you feel like serverless architecture for any company like that?
Yes, I think the serverless is really great. And as I said, I think the API in the push notification server could be replaced with the serverless architecture, and I think it would be really great. One thing why we did not do it is that how we are managing a lot of projects. We have, for us, it's really easy to deploy the new project and to balance it and do anything with it. It's just automatic job. So for us, it's very easy. Therefore, it was almost for us. It was almost the same to serverless or use this because the deployment is the automatic process in our company. But how I said, this is a good point, and I think in the future maybe we change the API to the serverless, which means that the request will be always accessible and respond. Any more questions? Yeah. Well, they did not allow us a roll-up or something, so I think I'm not allowed to talk about it much. Well, you can look to the Ackee and look what we are doing. You can connect me to LinkedIn if you are interested or if you want to ask for something. And there is a good GitHub of the microservices I showed you today. And the Ackee is doing primarily mobile applications. We are doing preferable startups. The projects are medium size usually, so it's about 1,000 to 5,000 work hours. And yes, we have this use cases for our servers, our clients, and this is one part how we deal with some of them. Any more questions?
Can you tell us of this your company, what's the benefit for you adopting microservices rather than applications? Did you see any improvements?
Yeah, well, I would say this in these projects where we used the gateway user service and the other microservices. Usually, in small projects, you have just 3 microservices. There is the gateway user service and some business logic. In these small applications, even in these small applications, it really helps us to separate some part of code. And I really see that if you keep code base as slow as possible, it's every time when you do anything with it, it's even more and more simple to do it. For example, we are doing microservices usually for payments. So this is already this is also a good thing to separate it. You have just one microservice which is communicating with some gateway to the bank, and it just creates you the link and things like that. And if it's not inside your main application, it's really easy to share. It's really much easier to maintain and do things like that. Any more questions? Okay.
Do you use Kubernetes and Docker, or how do you scale your microservice?
Yeah. We have all our applications on Google Cloud, and it's managed by Kubernetes and Docker. I am not the one who actually deploys it. We have also Jenkins for the continuous integration. So there is how we run the test and where the deployment is done. I just push to the development, and it's run on Jenkins automatically. It's deployed to the cloud, and everything works fine. Any more questions?
Yeah, it's time to clap.